Hey class, today we're going to continue on with chapter 4 about the atomic structure, and today we're going to start hitting on how do we tell atoms apart, or how do we distinguish one atom from another. So let's get started. It starts out with the question, how can there be different varieties of atoms? Well, just like there are different types of dogs, atoms also come in different varieties as well. We have nitrogen atoms, hydrogen atoms, basically any atoms that make up all of the elements. So what makes one element or atom different from another? Well, elements are different because they contain different number of protons. So hopefully you remember protons from an earlier lesson are positively charged. So protons, all elements are going to contain protons. And in fact, an element's atomic number is the number of protons in the nucleus of an atom. So atomic number is always going to equal the number of protons. And in fact, the atomic number identifies an element. If I said something had the atomic number 17, it's always going to be the element that has 17 protons. So if you change the amount of protons, you actually change that element. So the atomic number identifies the element. For example, if I said hydrogen, its atomic number will always be 1. Helium, its atomic number will always be 2. And since atomic number equals the number of protons, notice how these first two columns are always equal to one another. Another example is oxygen. Its atomic number is 8, and then its number of protons is 8 as well. Okay. So one thing before we go on from atomic number, please remember that atoms are electrically neutral, which means neutral has no charge. That means in order to be neutral, the number of electrons must equal the number of protons, because those two charges, what they do is they cancel each other out. So here, for a neutral atom, number of protons equals number of electrons. And we're going to see that right back here on this following picture. Here we have protons, and if you look at the column for the electrons, they equal 1 proton, 1 electron, 7 protons, 7 electrons, 9 protons, 9 electrons. Okay. So an element, nitrogen, has an atomic number of 7. How many protons and electrons are in a neutral nitrogen atom? So try pausing this video and seeing if you can get the following answer. So once you've unpaused this video, we know that the atomic number is 7. So remember, the atomic number equals number of protons, which means the protons equals 7. And remember, the number of protons equals the number of electrons. So that means electrons also equal 7. So 7 and 7. The second thing we're going to learn today is mass number. Mass number is also a very important concept. It is the total number of protons and neutrons in an atom. So if you actually had to rewrite this, the mass number equals number of protons plus the number of neutrons. So both of them added together gives you your mass number. So if you know the atomic number and the mass number, usually you can determine the atom's composition because it lets you find that last subatomic particle, which is the number of neutrons. So the number of neutrons in an atom is the difference between mass number and atomic number. So if you wanted to find the number of neutrons, you can take mass number, and it's the difference, minus atomic number. Remember, your atomic number is also your number of protons, so if you wanted to, you could also do mass number minus your number of protons to get your number of neutrons as well. Okay. So again, here's it written: number of neutrons is mass number minus atomic number, or it could be mass number minus number of protons. Okay. So over here we have the composition of any atom can be represented in a shorthand notation using atomic number and mass number. So if you ever see an element written as such, the atomic number is going to be your subscript. Sub means below, so it's the one on the bottom. So we'll write that over here for you guys. Bottom. And the mass number is the number which is the superscript, which is the top number. So just as a clarification and reminder, your atomic number is your number of protons. And so equals protons. And then your mass number equals protons plus neutrons. Okay. You can also refer to the atoms by using the mass number and the name of the element. So another way that you could write gold 197, gold, you can rewrite it as gold 197. So when you rewrite it this way, of course, this is the element. When you see this dash 197, this is actually your mass number. So remember, your mass number is protons plus neutrons. So over here we have a couple questions to see to make sure you guys are gathering and understanding this information. It's asking how many protons, electrons, and neutrons are in each of the following atoms. So why don't you pause this video and try to do these following ones, and then we'll go through the answers and see how you did. So let's pause it right now. Okay, welcome back. So right here we have Be. So hopefully if you pull out a periodic table, and I have one on my helpful links and resources, you're going to see that this element is beryllium. The bottom number is the atomic number. So atomic number. And we know that that number is equal to the number of protons. So there must be 4 protons. If the atom is electrically neutral, that means that protons and electrons must equal, so this must also be 4. And then to find the number of neutrons, remember we take our mass number minus our atomic. So this is going to be our mass number. So if we take 9 minus 4, we get 5 neutrons. If you look at letter B, the bottom number is the atomic number, so that's going to be the number of protons. If it's a neutral atom, the electrons will also be the number of equal the number of protons. And then for the number of neutrons, I have to take this top number, 20 minus 10 gets me 10 neutrons. And last but not least, we have Na, which is sodium. Down here, this is our atomic number. Our atomic number is always equal to our number of protons. And of course, if it's electrically neutral, that also equals our number of electrons. And last but not least, neutrons is found by taking the mass number minus the atomic number, which is 12.